So hello students, in this lecture we are going to see one more example on the Gauss Jordan method. So see here, find A inverse using Gauss Jordan method. A equal to this matrix is given, that is -1 3 5 -3 1 7 7 -5 -11. This particular example was also asked in 2018 for 6 marks. So let us begin with the solution. What we have to do, first step is we have to form an augmented matrix, that is A augmented I. So see here, I have written A augmented I. This particular matrix I have written here -1 3 5 -3 1 7 7 -5 -11, and we have to write here an identity matrix, that is 1 0 0 0 1 0 0 0 1. So now see here, what we have to do, we have to make this we have to convert this matrix A into an identity matrix. So see here, this is my first diagonal element and it is -1 here. My first diagonal element is -1, but I have to make it 1. I have to make it 1. So I have to perform some row transformation here. So I will perform R1 by -1. So after performing this R1 by -1, we will get 1 -3 -5 -1 0 0. So see here, I have make this diagonal element as 1 here. Now with the help of this 1, I am going to make the elements under it to 0. Which are the elements under this 1? -3 and 7. So I am going to make these particular elements to 0. So see here, I am going to perform here R2 plus 3 R1, as well as I am going to perform R3 minus 7 R1. So see here, after performing this R2 plus 3 R1, we will get 0 -8 -8 -3 1 0, and after performing this R3 minus 7 R1, we will get 0 16 24 7 0 1. So see here, in this way we have converted these particular elements to 0. Now next step is, this is my second diagonal element, this is -8 here, but in order to make it an identity matrix, we need to make it 1. So what we have to do, in order to make it this -8 as 1, so we will perform R2 upon -8. So after performing this R2 upon -8, we will get 0 1 1 0.375 -0.125 and 0. So see here, so we have converted this diagonal element, we have reduced this diagonal element to 1. So now with the help of this diagonal element, we are going to make this -3 to 0 and this 16 to 0. We will reduce it to 0 and this -3 to 0. So see on the next page, we are also going to perform some row transformation on row 1 as well as row 3 with the help of this row 2. So see on the next page. Yes, you can see here. So we have performed here R1 plus 3 R2 and R3 minus 16 R2. R1 plus 3 R2 in order to make this particular element as 0, and R3 minus 16 R2 in order to make this particular element as 0. So after performing this, this particular sign has also changed due to this row transformation. So see here, we have got this sort of matrix. Now see here, this is my diagonal element, we have converted it to 0. This is my diagonal element, we have converted the elements above and below it to 0. Now this is my third diagonal element. Now I have to make this 1. So I will perform R3 by 8. So after performing this R3 by 8, so it will reduce to 1, and this particular values will be 0.125 0.25 0.125. Now with the help of this third diagonal element, I have this 1, we have to make the elements above it to 0. We have to reduce the elements above it, that is 1 and -2 to 0. So now we will perform row transformation, that is R1 plus 2 R3 and R2 minus R3, and we will get this sort of matrix. So see here, we have converted this -2 to 0, this 1 to 0, and simultaneously this particular row transformation will also be applied on this side. So this is the answer of this row transformation. So see here, finally we have reduced the given matrix to identity matrix, and this is our solution. So this is our A inverse. So finally I can write here A inverse is equal to 0.375, 0.125, 0.25, 0.25 minus 0.375 minus 0.125, 0.125, 0.25, 0.125. So this is the inverse of the given matrix. In this way you have to solve it. So we will conclude for today's lecture. In next lecture we are going to see some other numericals related to this Gauss Jordan method. Till then, thank you.